Good morning or good early afternoon. I think we've just about ticked over. I'd like to thank David and Lee for asking me to come in and talk to you today. I love coming to these sessions, and I haven't been to one for a while because it makes me realise how small a part of the code that I actually use. And I've got so many more ideas of where I can actually explore this. So I find it really exciting. I'm a traditional CFX user. I'm being slowly transitioned into Fluent Mesh. I've had a couple of experiences with that. Not all positive, but I'm partially putting that down to user rather than the tools itself. But what I wanted to talk about today is how I use CFD and the ANSYS tools in the work that I do. I work in the built environment. I've been a CFX or a CFD consultant for 13 years, both in the UK and then based in Melbourne and now in Brisbane. I've worked on projects all over the world, so I've worked on the Sacramento Kings basketball arena in the US, to theme parks in the Middle East, to more sort of close to home projects here. When I talk to people about what I do, I didn't even know that was a thing. So what I wanted to run through today was some of the things that I do and that I look at and I think about, and hopefully, provide some inspiration on that. So as David said, I work for a company called Norman Disney & Young. We were recently bought, maybe 15 months ago, last January, by a larger company, Tetra Tech. Norman Disney & Young were 700 essentially building services engineers, so a company that looks at mechanical ventilation systems, electrical distribution, lighting, hydraulics, water movement, bathrooms, that sort of thing in terms of designing buildings. We were bought by Tetra Tech, so we're now badged as part of the High Performance Buildings Group, with our sister companies of Glumac and Cosentini, both in the US. But Norman Disney & Young, we've got, can't quite see it there, probably 12 offices around the world. I actually sit within the sustainability team, which people sometimes find a bit unusual. Where does CFD fit into sustainability and improving the environment? I started and came out of uni as a pure CFD person. I wanted to work for Formula One, but I didn't know enough about cars. So I kind of went into the architecture side, which was the second thing that I was kind of interested in. So looking at air movement around buildings, now that sits in the UK a lot with the prototyping, the simulation side, and energy efficiency of buildings. So I've started blending more into that. I still practice CFD today. In fact, I was issuing reports at 6:30 last night. Got to get this out. So very much still on the tools, but I'll now start looking at CFD and its impact that it can have on sustainability, either improved airflows in buildings, which reduces the amount of energy that can be used, to improving health and well-being and well-distributed, reducing air pollution, and really improving air quality for the general. So that's kind of how it sits there. And the sustainability focus within NDY is, and Tetra Tech as a larger, is very Australian heavy. So in terms of our group, our sustainability group, we probably practice in 3 key areas. We look at the advisory side. Now this could be anything from sustainability policy advisory. I particularly focus on buildings and individual buildings, but we do often look at groups of buildings or precincts and communities. But what I wanted to run through is the bit that I'm most passionate about is building physics, and how can we drive buildings harder to get the benefits, the reduction in energy, the improved air quality. We probably look at it in 3 key areas, so prototyping. Now that might be any sort of novel system that our mechanical engineers haven't designed before. The image that you can see over on the side is an natural ventilation system. We wanted to get some fresh air into a really deep plan building, so we looked at pulling some ducts down and naturally using step effect to draw some air through those. It's not really been done in that sort of building before. Obviously in the Middle East you see a lot of that sort of wind tower and that sort of architecture. Look at an analysis, so things like wind microclimate on the outside of buildings, preventing strong gusts, as well as improving thermal comfort, so making sure you're reducing urban heat island effect. And then we get into the optimization, where we will look at a number of different scenarios to try and get to the best, either most cost-effective, energy efficient, and really balance across those variables. So I'm really interested to see where we could use some of the Discovery Live. I've got a project in my head already, which I'm going to catch you about afterwards. So I'll just run through a couple of the actual projects that I've worked on and applied some of the ANSYS tools in CFX and CFD simulation. So Bakehouse Quarter, this is a precinct development down in Sydney, just on the outskirts of Sydney. It was the old Arnott's biscuit factory. So there's a lot of heritage buildings there, but they're really looking at developing this into a multi-use site. They'll look at having education within that site area. There's probably maybe 20 buildings in there. So they'll look at having education, healthcare, residential, commercial. So it really is a mixed use development. But one of the key things, and you can see from some of these images, they really want the outdoor space to be comfortable and used for a lot of the year. So what we go through and went through and looked at was how can we actually start to influence thermal comfort on the ground plane for people that are using that space. First of all, we'll focus in terms of thermal comfort, how comfortable you feel. Combination of air temperature, airspeed, humidity, and solar radiation. So one thing that you can either get really right or really wrong is the location of your buildings that can produce funneling effects. If anyone's been down in Docklands in Melbourne, that whole suburb is what not to do in terms of putting buildings at the mouth of the river to accelerate wind flows down the street. So we're making sure that we're not inducing any uncomfortable winds, and so you can see with the downwash that's happening on the bottom corner, flowing straight onto a green pedestrianised roof. So that's a roof terrace. They want to be able to use that throughout most of the year. Now, unless you put any sort of texturing on that facade, people aren't going to be able to use that space. You sit outside in cafe areas, and your newspaper gets all blown. You're not going to go back there. So it really does have an impact on how the development will operate in reality, not just from an aesthetic. Yeah, we think this will be a great idea. So really using evidence-based design to develop the design. One of the projects that I worked on at one of my previous companies was a development like this in Singapore, where they actually, and I've done one in the Middle East on Masdar City, where the architect and master plan gave me what they wanted, and then they gave me free rein to do what I wanted. I was sat in a room for a week with an architect. He'd give me a model by the end of the day. I'd run that overnight, come back the next morning and go, right, that bit doesn't work, let's move this, let's do this. So it's not quite the Discovery Live speed, we're still talking 12 hours per run, but there is an opportunity to be able to do that and influence design that way. This was a recent school that I worked on. Again in Sydney, so there's a large 3-storey atrium in the middle of the of this new music and drama centre. Instead of providing air conditioning, therefore using energy for that particular atrium, we wanted to see if we could actually get it to work with natural ventilation mode, still trying to get lots of nice fresh air and try and keep it relatively cool without the extremes that Sydney can experience. Now, when it's 40 degrees outside and without any mechanical or air conditioning, it's going to be at least 40 degrees inside by bringing outdoor air in. So there's a couple of things that we looked at, like using spill air from classrooms to try and moderate that temperature. Obviously, things like the glass performance and the insulation have an impact as well. But and this is very much sort of early concept, so the architect is still in concept design. Again, this was a great project, as I said, put windows wherever you want, put louvers wherever you want, we'll make it work. Very rarely do I get that response. And I think the last one that I wanted to talk through, again, external plume and heat dispersion on a data centre. So we've got a heap of condensers on the roof. It was someone's smart idea. These are the emergency generators that fire up. And then this is where all the cooling is provided. So there's a huge amount of recirculating heat. And we were able to identify where that was happening and then look at different options. So we were looking at things like changing the grate porosity that these condensers were sat on, putting sort of physical solid barriers at the ends of the condensers. We probably tried 3 or 4 different options and got to something that was workable, but you could still easily maintain these bits of kit. There wasn't the option to actually move any of these things. We were a bit late for that, but if we hadn't have flagged this during the design stage and it had got to operation, there's you probably derate the cooling by about 20%, so you'll lose 20% of your cooling capacity. In a data center, that starts frying the chips. So you've really got to be aware of some of this stuff. So that's a really quick run through. I do heaps of other stuff, but yeah, come and give me a shout. I'm going to stick around for maybe the next 20 minutes over lunch. Come and give me a shout if there's anything that you're interested in or want to talk about more. But thanks again for
Thanks very much.
today.